On September 25th, the Sun erupted. A coronal mass ejection shot across space, releasing billions of tons of plasma and superheated particles racing outward at millions of miles per hour. Most of the time, these storms scatter harmlessly into the void. But this one did not. It lined up almost perfectly with 3I Atlas as it passed near Mars. With that kind of destructive force, many comets would not survive. In recent years, we've seen comets like Ison and Leonard disintegrate in dramatic fashion as they neared the Sun, bursting apart under heat, pressure, and sublimation. In fact, studies show that nearly 1 in 4 long-period comets breaks up entirely before or during its closest approach. Yet 3I Atlas passed through this solar maelstrom virtually unscathed. That resilience suggests a durable nucleus, or perhaps even a protective plasma shield surrounding its core. Then the cascade began. Within days, stars exploded in distant galaxies. On Earth, Venezuela was jolted by massive back-to-back earthquakes. Natural events, yes, but clustered so tightly around 3I Atlas's solar encounter, they raise a sharper question. Is this coincidence or entanglement? What hasn't been widely reported is that 3I Atlas has pierced our heliosphere, a 9.3 billion-mile shield created by the solar wind that blocks nearly 3/4 of the cosmic radiation drifting in from deep space. If that barrier is broken, radiation can enter. Some geophysicists warn it can disturb the Sun and even shake the Earth beneath us. Could those recent earthquakes in Venezuela be a result of this? NASA's response was swift. Just one day earlier, on September 24th, a SpaceX Falcon 9 rocket lifted off from Kennedy Space Center, carrying the Interstellar Mapping and Acceleration Probe, IMAP. This probe is currently racing toward the L1 Lagrange Point, nearly 1 million miles from Earth, to study and map the heliosphere. To understand how particles move and trace the edges of our protective bubble, NASA insists this is routine science, but the timing suggests urgency. 3I Atlas breaches the shield. IMAP is launched almost immediately. Is this coincidence or a rapid effort to assess the damage? Because remarkably, IMAP carries the exact tools you'd need to measure a surge of cosmic radiation streaming through a compromised heliosphere. The High-Energy Ion Telescope tracks fast-moving particles. GLOWS detects the ultraviolet glow of solar wind across the system, and IDEX analyzes interstellar dust itself. Officially, they're for science. But in this moment, they sound like instruments built for 3I Atlas. Did 3I Atlas leave a gaping hole in our galactic protective shield? Are cosmic rays and interstellar particles streaming towards Earth? If the heliosphere is our outer shield, the magnetosphere is the inner one. Generated by molten currents in Earth's core, it bends the solar wind, blocks the deadly spray of cosmic rays, and protects the atmosphere itself. Without it, radiation would strike the surface directly. Life would not endure. But that field is weakening. For decades, the field has grown thinner, leaving Earth more exposed. And nowhere is the decline more visible than over the South Atlantic. Scientists call it the South Atlantic Anomaly, a vast region above South America where satellites short-circuit, computers reboot, and cosmic radiation plunges closer to the surface. Each year, the anomaly expands, swallowing more of the sky. The bubble that protects us is not uniform anymore. It is cracking. So imagine this moment. Atlas pierces the outer heliosphere. The Sun erupts with storms, Earth's magnetic field falters, and the South Atlantic anomaly widens. Our two great shields, the heliosphere and the magnetosphere, strain at the same time. The question is no longer if these defenses are weakening. The question is whether they can hold when the next wave of solar storms arrives. And IMAP isn't the only eye on the object. NASA has already retasked orbiters around Mars to scan 3I Atlas as it sweeps past. Every agency is watching. The sudden storm of coincidences, eruptions, supernovae, quakes, and now a breach of the heliosphere, all drive one question. What exactly is 3I Atlas? New data shows 3I Atlas is far more massive than first thought. Its minimum mass is already staggering, more than 33 billion tons, and new calculations suggest it could stretch up to 46 kilometers across. That would make it larger than Manhattan Island, a behemoth unlike anything we've ever seen enter the solar system. And its behavior only deepens the mystery. 3I Atlas is moving fast, far faster than models predict, about 60 kilometers per second. Instead of plunging in from a random angle, it arrived perfectly aligned with the plane of the planets. A chance astronomers say is no better than 1 in 500. Its chemistry is stranger still. A glowing green coma rich in carbon dioxide and cyanide and laced with nickel without iron, a signature far more common in refined alloys than in nature. And its very presence is a paradox. By every estimate, we should have seen hundreds of thousands of smaller interstellar fragments before a giant like this. Instead, the giant came first. Now, the wait is on. NASA has retasked the Mars Reconnaissance Orbiter, whose high-rise camera could capture 3I Atlas as it sweeps past the red planet. At 30 meters per pixel, the image may reveal its true scale. Other orbital scanners will probe its strange glow and test whether this is simply a massive comet or something altogether different. The sun grows restless, Earth's defenses are weakening, and 3I Atlas keeps moving closer. We're watching history unfold in real time. What do you think 3I Atlas really is? Leave a comment, join the discussion, and don't forget to like and subscribe. Because together, we'll follow this mystery wherever it leads.